Okay, people in the chat, tell me if you can hear me. Okay, I guess people can hear me. Good morning, everybody. I've got a bit of the hiccups. It is 0500 here in Hawaii, so forgive my voice. But I'm here with Professor Phil Bell, a physicist. Okay, people in the chat, tell me if you can hear me. Yep.
Yes, hello.
Okay, I guess people can hear me. Damn it. Give me a second. Everybody, I've got a bit of the hiccups. It is 0500 here in Hawaii, so forgive my voice. But I'm here with, all right, sorry, I had that playing in the background. Yes, so Professor Bell is here. He is a professor of physics. And what we're doing today is we're going to have a bit of a chat and take audience questions. Of course, super chats get preference. And we have an open challenge out to any flat earther who wants to join. The rumor on the street is that Quantum Eraser has said that he will be joining to challenge Dr. Bell, and we're willing to have him. All he has to do is click the link and join. Dr. Bell, how are you this morning?
Very well, thank you, and looking forward to this little chat. I've quite like your channel, and I'm also very grateful for that boost from about 400 to about 700 subscribers that all of a sudden happened as a result of you putting one of my videos on your channel.
Yes, sir. That was my pleasure, and that was a great video that you put out. And if memory serves, the gist of it was that there's no excuse to be uneducated in these days, because we have access to all manner of information that's just there for you to seek out and find.
Yes, I think the main point that I wanted to make there was that if opportunity didn't come your way for one reason or another, because lots of people may want to become educated, but then things do get in the way, and life does get in the way sometimes. In fact, quite often. You might be in high school, and then you might find yourself pregnant, or whatever reason. There's many things that get in the way of your education, that can get in the way of your education, and certainly your financial situation can be that. It's a very unfair system. However, that is not an excuse for then, when given the opportunity later, to not seize it. That I don't get. And I think that was the point I was trying to make. Okay, somebody in the chat.
Yeah, while we wait for some questions to pop up, can you tell us a bit about how you got your start and found your way into the realm?
Yeah, look, I think if people say you were born a scientist, my mother would probably say that I was, because I blew up my hand and ended up in hospital when I was probably about 8 years old. And I was forever, I've set the kitchen on fire a couple of times, just when I was a kid. And so I was always, everybody was wary of Phil's mixtures. And I was fascinated by the idea of things exploding. There was a big fascination with that. So when I did graduate, I actually did my A levels. I was about 13 years old, I think, when I did that. I had a teacher who could see the passion that I had even as a little child, and fostered that, and then introduced me to a chemist who taught me chemistry, and then eventually taught me mathematics and that. And so I did my A levels quite early. So school after that became a little bit boring. They wouldn't let me do stuff that I wanted to do. I still had to go through the usual things that you have to, learn the basics in algebra and so on, which of course I already had by then. Anyway, after graduating, my first job was in an explosives laboratory. So that was that was a good place to get, until I realized that in the real world, when you are playing around with explosives, there are some real risks associated with that. And I just thought about it. I thought, well, there are certain risks here that I'm not really that happy about taking. So eventually I decided to move to other areas of chemistry. And then after spending many years in that area, I decided to get to do some geology and geophysics, and then into pure physics. So this is so I can actually can straddle both of those areas, physics and chemistry. So happy to discuss either of those.
Yeah, physics is really a passion of mine, and chemistry is that elusive thing that I regret that I never really got as deep into as I want to, because it seems to me like chemistry is the basis of all other science. If I'm understanding it correctly, you can't really have anything if you don't have the chemistry that undergirds all of it. Yeah,
the physicists would argue with that. Luckily, I do straddle both sides. So if I'm sitting with some physicists, I'll argue that it's the physicists that drive the whole thing, and if I'm with the chemists, I'll argue that it's the chemists who do it. Actually, they the physicists tell you how things work, and the chemists tell you what will happen. So it's kind of like that. You could break it down to that. So what's going to happen in terms of chemistry? For instance, one of the things I'd like to discuss with you is, for instance, the Haber process, which is the creating ammonia from hydrogen and nitrogen. So what would the physicists say about that? The physicists would say that the process by which hydrogen and nitrogen get together, so pressure, temperature, those are the things that are required to cause this reaction, perhaps even a catalyst, to cause this reaction to happen. And the chemist would be more like, how much nitrogen and how much hydrogen will I need to produce X amount of ammonia, and how much time would it take? So that would be the chemist's point of view. So chemists are interested in, what do you do? How do you create this? How do I make a new polymer? The physics is more about, how do these atoms get together? What is the energy that they have collectively? What energy is output into the system? From out of the system, what energy is required to go into the system? A physicist would probably discuss that.
Yeah, and both disciplines are endlessly fascinating to somebody like me. We do have a super chat. I'm sorry for these hiccups. Nothing I can do about it. From Christ Buncher, who wants to know, when is the best time to buy a house? I think that maybe was said in jest.
Okay. Yeah.
I'm looking for questions in the chat for Dr. Bell. If anybody has any, and again, super chats get priority.
Well, here's a good chance to ask some questions. I'll probably, I can only do my best to answer questions. I'm not the fountain of all knowledge, but in the 46 years I've been at it, sort of been around the block a few times, and I might be able to answer your questions. So if you do have some questions in the chat, please feel free. Here's an opportunity. And then what we can do is not only just answer questions, but I'd like to answer some specific things that come from the flat Earth realm, and see how we can deal with that. And maybe there'll be some flat earthers in the chat who would like to ask a question with regards to that. So if that's fine with you, I'd like to
Yes,
do it.
sir. They are always very, very bold until it comes time to put up.
Yeah, so I think one of the biggest things that I've noticed, and again, I'm new to this debate, if you want. I don't like to use the word debate actually, because I don't think it's fair. It's like if quantum eraser did come, uh, um, and I don't mind if he doesn't, you know. But I'm at a huge advantage, which isn't kind of fair in a way. That's why I don't like to call it a debate. I'd love to have a little chat with him or with a flat earther about this, but to call it a debate would then say that we have equal advantage, and we don't. I have a huge advantage. The biggest advantage I have is not my training in science or anything. It's that if the argument is the Earth flat or is the Earth spherical, my advantage is that it is clearly spherical, and because of that, my advantage in terms of evidence is so much more. So that's why I say it's not a debate.
Yeah, and when I heard that the QE said he was going to show up, I immediately was incredulous. He's made threats before, saying that he was going to make videos about me and level certain accusations, and they've never he's never been forthcoming with that. It looks like we do have a question.
Yep.
Is the universe round?
Oh, that's a great question. All right, so obviously this is one of those things that you have to use what you've got, you know, your accumulated knowledge, to see if you can at least reach some sort of deduction about what that might be. So let's say, for instance, that we accept the principle that the universe started from a singularity and moved out from there, so expanded from a singularity. And there is evidence that this is what happened. Right? So we're saying the model that we use that describes how everything began is the Big Bang, and it's based on some pretty sound and compelling evidence, especially with redshift and blueshift. Okay, so if you accept that, we now have to say, well, is based on the laws of physics that we have, that we can observe here on Earth, you know, where things will move out uniformly. If they are going to move out uniformly, then it must be then the universe must be spherical, because in its outer reaches you'd expect it to be spherical. So the question is, to answer that question, I would deduce that it's spherical based on the fact that there's a uniform expansion of energy. What do you think of that?
Yeah, I would agree with that. If just based on the CMBR, the way that I look at it is that if you're in the middle of the ocean, you can see all the way to the horizon in every direction. So from your perspective, you're in the center. No matter where you are, you could be near a coast that's just beyond your horizon, but you don't know that. You seem to be in the center.
Yeah.
So from a layperson's view, that's sort of how I look at it. We have a super chat here from John Regato. Many thanks to Professor Phil for every bit of abuse he takes from the unenlightened. Others learn that's answering a high call. Respect is due, and I agree with that. And that leads me to a question. How is it that you found yourself in amongst us misfits who debunk flat Earth and other nonsense?
Oh, look, I was on Facebook, and I use that to catch up with people that I don't see for a long time, and I don't know, somewhere in my feed came up this thing where somebody somebody made a comment, it's totally incorrect about science, and I casually said to this person, I guess you think the Earth is flat. Now, for no other reason. I didn't know about flat Earth. I didn't know that people these days actually thought the Earth was flat. I knew that they did, 3,000 years ago, but I didn't know that they did now. So I just said, backhanded, quip, I guess you think the Earth is flat. And from there, this person said to me, yes, I do. And I couldn't believe what I was reading. He then said, here's a link. I went, well, I've got to have a look at this and see where this takes me. And what a rabbit hole that turned out to be. Gosh. So I'm still friends with this guy, and I want to punch him every time, guys. If I come across him in real life, I think I'll punch his head in for leading me down this.
We have the flat earther Chris Berry in the chat, who says the Earth is obviously stationary and flat. So I asked him if he would like a link. Let's see if he's a coward or not.
Oh, I've spoken to Chris before, so no, he's all right. He's okay. So I'll be more than happy to speak to. But Chris, if you don't come in any case, no, it's not. So Chris, what you see for yourself, you don't notice that something's that the Earth is moving, right? So you immediately just say, well, it must be still because I can't tell that it's moving. All right. So this would be my advice to you, Chris. Get together with your best friend if and when you're allowed to. Make sure you wear a mask. Get together with your best friend, and go off to a kiddie's playground. Now, find one that has a roundabout in it. Now, whoever is the smarter of the two of you, stand on the roundabout. The other one, push. Now, make sure that you bring your cut lunch and some dinner, because you're just going to push this thing around so that it goes around once in 24 hours. And then when you're finished and done all that, meet me online and explain to me how you had to hold on for dear life in case you fell off. And tell me how you actually noticed at any stage that it moved. That's kind of what you say. Hope that helps you, Chris.
Well, it appears that he has disappeared.
Okay.
Which is it is something that he's well known for.
Okay. Well, hopefully everyone else got that anyway.
Yeah. When hard questions pop up, he needs to walk his dog all of a sudden.
That's all right. I can see a man like me. Man, I actually argue quite a bit with a man like me, but he doesn't respond to me anymore. But I'm happy to answer any questions that he has.
The black swan.
Oh, the black swan thing. Oh, yes. Okay, let's work on that. Yes. So the black swan picture, when that first came out, I think it took about a minute to look at it and say, well, gosh, have a look at the cranes. I mean, really, if you're intellectually honest, you got to look at this picture and say, well, just about everything you're looking at this is distorted. So if you were going to base any decision, any conclusions based on this particular photograph, you couldn't. Whether or not you would you'd make a conclusive, about how far things were, this would be a very, very difficult thing to conclude. Okay, so you would not use this photograph in a serious discussion about the horizon and the distance to the horizon, simply because it's so distorted. So you'd know that the horizon was distorted. Whether or not how much it was distorted, you couldn't even tell from that photograph. However, one thing is obvious though, and that is that you can see the towering effect on the cranes. The thing about looming and towering is that they're not selective. They'll loom and tower whatever object there is, and one of those objects is the distant horizon. So they'll loom that as well. So it's going to look, for all the world, for someone looking across at it, as if the horizon is further away than it actually is. That's because it's loomed up. So the idea that you'd come on with this and then say definitively this proves that the Earth is flat. Well, I mean, I'm not surprised, because you're saying that the Earth is flat, so you're introducing this notion already. I mean, you're already saying the Earth is flat, so really anything else that you say is not going to be surprising. But to base your argument on just this one photograph, but it gets worse, you see, because the person who took this photograph also took a photograph of the same rigs from the same location, and on a normal day, when there's not so much distortion, and lo and behold, half of the rigs are gone. You can't see them. That's because they're beyond the horizon. Well, then you've got some flat earthers who'll argue and say, well, we can't see the bottom of it because of the limit of diffraction. So they've cottoned onto a word like diffraction and the Rayleigh criterion, cottoned onto those things, and not actually even had the intellectual honesty to go and find out what these things actually mean. What is diffraction? Diffraction is a very, very highly defined concept. It takes, when I teach this, it's a good 3 weeks worth of lectures and, notes and all of those sort of things and tutorials and that to get through just this one thing. So it's not a small subject. But at least go and find out what is diffraction. And then you would realize that diffraction can't happen to just one portion of the object. Because all parts of the object are approximately the same distance away from you, the limit of diffraction will be the same for all parts of that object. So it's impossible for you to say, well, I can't see the bottom because of the diffraction limit, and yet I can clearly see the top of it. And not only can I see the top of it, because normally if something reaches the diffraction limit, what it means is that any two parts of it seem to coincide, so that you can't tell the difference between one object and everything seems to come together as one object from all directions, by the way. So
yeah, from what I've seen lately, it seems to be that they're saying if you make one observation and there appears to be high refraction, and there's another another picture from the same spot where there seems to be very little refraction, both of those represent reality, and I think that's just them falling on their sword.
I don't think they realize that they are doing that. That's the thing about it. So I think one of the things, if you can take anything away from that and take it away from this moment, that I would say to the flat earthers, okay, find another reason. Drop diffraction, because it's obviously not that. So now, if you think that there's another reason why you can't see the half of the rig, why half of a wind turbine is out there, you can actually see the turbine turning, and it's in the water. You know, it looks like it's in the water. Explain that, but don't use diffraction, because that is not the reason. Okay, so there's a flat earther I come across quite often. His name is Gary Whitebanker, who uses this diffraction thing, and I think Oakley does, and Rayleigh and those. I think they also do that. Forget about diffraction. It doesn't happen. Why don't you go and learn something about what diffraction is? Come up with a new form of physics, write a paper on it that explains why you can't see the half of the rig or half of the wind turbine. The current model works. We could actually make predictions about how much you should see, and they work. These predictions actually work. Now, if the model that makes these accurate predictions that actually work, you come up with one that works even better, or at least as good. You're simply saying the word diffraction is just a total waste of time, because you bring nothing with that. At least if you bring with the diffraction, show us in the diffraction formula, show us how only half of diffraction applies to only half of the ship or half of the wind turbine. Now,
yeah, Chris Berry is still in the chat. Chris, if you want to make a run at myself or Dr. Bell, then get a link and come in here. Otherwise, you're just pissing in the wind.
okay, so all right, so I want to talk about the scientific method a little bit about that.
Please do, sir.
That's often something that's mentioned. Okay, so I wrote down a couple of notes here. I might just have a quick look at what I wrote down. Okay, what is the scientific method? Well, first of all, it's a framework. So let's call it that, a framework by which you could rely on to make and to do an investigation about some observation that you've made, some physical observation that you've made, and you want to find out, you know, what makes that work, right? Which is a natural thing that us humans do. And the scientific method is a good way, is a reliable way to be able to say, well, if you follow this framework, then it's likely that at the end of it, that we'll all be talking the same language, and other people who look at what you do will be able to repeat what you do, and then reach the same conclusions that you do. So, and it's a method, a framework for investigation. But within this framework, there are as many ways to do this. Are as many approaches to this within this framework as there are questions. So this idea that you have to follow a particular set of, you know, every single experiment has to follow an exact set of rules is just nonsense. You've just got to stay within this framework that is there. Now, so that's the one fallacy that they make about it. Then if you want to break down the further things that they say, for instance, the latest things that they're saying is about hypothesis, and of course in science we say we don't try to prove things, and apparently this caused quite a deal of mirth in some of the channels like Oakland's, because they seem to think that that the whole idea of science is to prove something. Well, the scientific method in particular isn't about proving anything. It's about amassing more evidence, okay, so that you can draw a conclusion about things. It doesn't say anything about proof or truth. And the reason that it doesn't do that is because those things can change. We can get better instruments. We can get better precision. And sometimes a model that we thought, well, that kind of works, and then someone else has come up with an even better model that says, you know something, this one works even better. And that will be the one that's adopted. So did that make the previous one a lie? Of course not.
Yeah, and oh, go ahead.
Well, I mean, falsifying is an important part of it. Otherwise, because as sure as hell, if you don't do it, someone else will do it for you. Okay, so because the one thing about science is that when you do come up with something and make a bold claim about and reach a bold conclusion about something, someone is going to want to knock that down, and they make a name for themselves by knocking it down. So that's not a bad thing. That's a good thing. That's because people get together and check the veracity of what you say. So yes, to answer your question, part of an investigation is to find out how could I falsify this, and by doing that, that's how you collect your list of things that you want to control. That's how you know what your controls are. Okay, so what are the things that might affect a particular process?
Yeah, a lot of science to me seems to be we're just shortening or making smaller the error bar as our methods get better. Measuring things.
Exactly. So
we got another question that I thought was a good one from John Rapp. Said, could Professor Bell comment on the bad terms that flat earthers use, like spinning ball, vacuum sucking, cause and effect, Coriolis, and Earth spinning underneath, second law of thermodynamics? That's a lot to unpack there, but if you would.
And all of these words are used either incorrectly or not within a correct context. For instance, one of the biggest ones is the second law of thermodynamics, used a lot, and I would bet that most of the flat earthers who use that don't actually know anything about it and what the second law of thermodynamics is, and how it might or might not affect their argument. So their argument is this: that Earth could not have an atmosphere because of the second law of thermodynamics, even though the second law of thermodynamics doesn't specifically argue that, doesn't actually cover that. The second law of thermodynamics is really about entropy, and that is things that move from an ordered system to a system of chaos. So in other words, and that means that basically energy is eventually spread out, if you like. So it's from energy that's in a single place, if you like, and then eventually it becomes spread out. It becomes less and less ordered. And that's basically what we're talking about when we're talking about entropy. And that's a word that's misused a lot. Spinning. The word that's used, it's not because spinning is a wrong word. It's the connotation of that is that it's moving fast. Okay, so if something goes around once in 24 hours, you say it's spinning. Well, I guess it is spinning very, very slowly. and so you wouldn't feel it, would you? But I mean, that's the sort of reason that they use that for effect, not and sometimes by some of those channels used for dishonestly in a way.
Yeah, because the way that the human body interprets motion is the fluid in the inner ear.
Yeah.
And the rate at which the Earth spins would not even disturb that fluid in any way that you would feel it.
Not only that, it would need to accelerate for you to feel it. You need to have a significant acceleration that would overcome the pressure on the ear, the inner ear, in order for you to actually detect that. So, I mean, we have limitations, and I guess this is one of the other things that the flat earthers don't understand. I mean, they say, well, you trust your eyes. Gosh, your eyes are probably one of the least things that you would want to trust, because I mean, they're so easily fooled. If they weren't, there wouldn't be people like conjurers and magicians. If you could trust your eyes, optical illusions wouldn't be a thing. Diffraction wouldn't be a thing. Things, a railway line coming together from perspective would not be a thing. If you could just trust your eyes, you look at that and say, well, you can easily be fooled. People who watch that Black Swan thing are fooled all the time. I'm joking.
Yeah, have you seen the video of the maglev train in Japan? It's going something like 150 kilometers an hour, and there's a coin up on the ledge that's sitting up on end, but the maglev train is so smooth that it's not. Oh, yeah, jeez, my hiccups. It's not knocking it over.
Oh, absolutely. So I haven't seen that particular thing, but I've been on fast trains many times, and certainly very fast airplanes, and I don't seem to have any trouble putting my coffee down, and it's not spilling all over the place. And if the train did come to a screeching halt or whatever, then of course I would lose the coffee. But and acceleration does that, so acceleration would change that. But if it's not accelerating, you can't tell it's moving. Close your eyes. You can't tell it's moving. It's only these little bumps, little changes in acceleration that cause you to be able to feel that it's moving. So this whole idea that you should be able to feel the Earth, the motion of the Earth, you wouldn't.
No, not at all.
No. So
talk about the. No, go ahead.
Flat earthers, please lose that one. Hopefully in this little hangout that we're doing tonight, we can throw away some things so that we can try to get on the same page as much as possible. So try it like you would if you were in a court case. The whole idea about getting together before the court case in a deposition is to be able to reduce the arguments, the amount of arguments. Try and get the arguments down to as few as possible. So let's try to do that between flat Earth and spherical Earth. Try and reduce what it is. So diffraction, out. Don't mention that again. Okay? Can't feel the Earth move, out. Don't mention that again. Let's see if we can't knock a few more over. Oh, by the way, second law of thermodynamics does not apply to the atmosphere because there are other forces that hold the atmosphere down. So that one, out. And if you want to use the second law of thermodynamics, fine. Come with the science. Come with the equations. Come with the mathematics. Show us how, in fact, you're correct on that point. And if you think that there's a dome over the Earth, come back with the evidence. If you don't, it's out. So let's lose that one too. Let's see if we can bring this argument back down to a few strong ones that both of us can argue with.
So John Rapp for $2 says, thank you, Professor Bell and Schrodinger's cat. And Illy Moon says, what was Aries' failure experiment? And she wants flat earthers to please listen.
Okay, so Aries' failure is about well, both the Aries failure and the Michelson-Morley experiment are about determining whether or not an ether exists. It had nothing to do with the motion of the Earth. The whole idea of it was to work out whether or not light would change, would be different in one direction or another because of the influence of an ether that's in there. So, and the reason that both of those, they failed in their hypothesis. So the alternative hypothesis was adopted, which was there's no ether. Well, certainly there was no detectable ether.
Yeah, I don't know why flat earthers have so much issue with that.
Look, they have to put it this way. Look, I stand corrected on this if need be, but there's a group of flat earthers who are, if you like, the arbiters of flat Earth knowledge, and it started with this. From what I understand, I haven't been here that long. From this guy called Eric Dubay, apparently. Who was reiterating a lot of stuff that was done by quite a famous flat earther, I think it was called Rowbottom. And so this Eric Dubay, I think, put it all together, and in some sort of book or whatever it was, a set of videos, 200 proofs or something like that, and included some of this misinformation in it, and basically what he was trying to do was to assemble as much small pieces of evidence as possible to sound convincing, but falsely. So in other words, these things are not true, but they just sounded like they could be true. And this is the thing. If it sounds like they could be true, then the flat earthers are quite likely to latch onto it as if it is true.
Yeah, so Eric Dubay was on the scene and discredited well before URI came on the scene. He's been beaten down so many times, and yet his arguments still persist. I still hear them over and over from flat earthers, no matter how many times they've been knocked down. Yes,
yeah, no, exactly. So one of the things that he did mention was the idea that that Earth was has this is not only does it's flat, but it's surrounded by the Antarctic continent. So if you look at that objectively and say, well, okay, let's and it's stationary as well, okay. So if we try to look at that objectively, there's a couple of questions that you've got to ask yourself. And if you don't ask yourself these questions, you're not being honest with yourself. So let's see if we can just ask a couple of them. Well, in Antarctica, this is a continent where people live. People live there, okay? Like their house is there. They there to support the throngs of people who come there in the summertime to visit. Okay, there's a highway. There's a highway called the McMurdo South Pole Highway, which is traversed by people in the summertime who go from McMurdo to the South Pole. This happens all the time. Well, you need the infrastructure there to be able to support these people who are doing this. And there's a huge crowd of them doing it now. Okay, it's not like it's a half a dozen scientists who go to Antarctica anymore. Thousands of people go there all the time. in the summer, throughout the summer season. Okay, so there's two stations that I can think of. There's Davis, which is owned by Australia, and there's McMurdo, which is the American one. They are always in contact with each other. They are on opposite sides of the continent, pretty much. So, if you look at them on this flat Earth map, they are on opposite sides of the Earth. Can you please explain how they both have noon and see the sun at the same time, if that's the case? You see, you can't undo the fact that they exist. This is just a fact. McMurdo and Davis exist. These stations exist. People live there. You can't undo that. Now, you look at your model that says that one is on this side of the world and the other one's on the other side of the world, and they're both experiencing noon and seeing the same sun at the same time. Which one of those are you going to throw out? Are you going to throw out the model, or are you going to throw out the facts? What I find in this flat Earth thing is they'll throw out the facts, believe it or not. So that's just a simple example.
It's similar to someone in Australia and someone in South Africa who both see the Southern Cross. Exactly. They're both looking south, but yes, they're on other sides of the planet, and on the flat Earth model, they'd be looking in entirely different directions. And the only flat Earth rebuttal that you get is, well, we don't know what stars are.
Well, the thing about it is that, all right, so as I said, let's try to limit the argument. Try to, both of us, get rid of the superfluous stuff. This AE map as a model for flat Earth doesn't work on so many levels. Apart from the fact that, you know, the sun is wrong, the distances are ridiculous. I mean, here in Australia, if you believe that, then in the summertime the sun must be traveling at 3,000 miles per hour in order to get around the same distance. It's just so totally ridiculous that you've got to look at this and say, no, this AE map doesn't work for flat Earth. Find one that does. It's okay. I'm fine with you looking for a model that works. This one, ditch it. This one, get rid of this one out of the argument. Because if anything is making your argument look idiotic, this map is. As I've just pointed out to you, are you going to decide that Davis and McMurdo don't exist, despite the fact that thousands of people visit there all the time? Or are you going to just say, well, that map's wrong? So I hear often people like Oakley and Quantum Eraser will say, well, but we don't have a model. We don't have a map. We don't have a model. Well, my answer to that is, what the hell are you arguing about then, if you don't have one? Because you need to bring to the table something useful. What do you want me? Do you want me to quit my job because you don't have a model and you don't agree with the model that I'm using that works? The one that I'm using works. What do you want me to do? Drop what works for me, drop that, forget about it, and adopt your idea, and you don't even have an idea for me to work with. How am I going to do my job? Let's say, for instance, I was a military person. You know, there's a few, yourself, yeah?
Yes, sir.
And you've got to fire a missile. Well, you've got to hit that target over there. Now, you know that when you fire a missile, it's going to take a parabolic path towards your target. There's two vectors involved in that. There's the vertical vector and there's a horizontal vector. Okay, well, the vertical vector involves gravity. It involves our knowledge that it's going to come down at 9.8 meters per second squared. Now, that works. The Navy, they actually do hit the targets that they want to hit most of the time. These ordnance are very, very expensive. You'd want it to hit the target. Okay, so can you please, if you want the Navy people to drop it, gravity is not a thing. So forget about it. Newton was an idiot. Forget about it. Gravity is not a thing. Please, can you please explain to the Navy how are they going to hit the target now without calculating the projectile motion without gravity? Are you seriously expecting the Navy to forget about projectile motion and gravity while you figure out some new formula that does not involve gravity?
Right, and I've shown flat earthers.
The Navy's going to do.
I've shown flat earthers time after time our field manuals that show that the equations we use have gravity as a factor, and it's just a hand wave dismissal from them.
Yeah, I'd like to know how all of these things that happen. How on earth do they how do they expect to be able to achieve what's ordinarily achieved all the time without it? So let's say, for instance, you're an engineer. I mean, this is just an everyday thing. You've got a 40-meter span across a room. You've got to put a beam across that room. Okay, and you don't want to have a center. You don't want to have a center pillar. You just want a beam straight across the room. It's an auditorium, so you've got to have this beam. How are you going to determine the size of that beam? Which formula are you, Flatty, going to use that does not include gravity, that does not take into account the stress and the strain? And gravity will cause it to sag in the middle, so that you can decide what width to make this beam. Please explain how you do it. Please explain, if you're a shipwright, how you're going to work out the buoyant force without the use of gravity. How are you going to do that? How are you going to decide what size to make the draft? Are you just going to build a ship in the hope that you get it right? Or are you going to get the engineers to actually design the ship with the correct draft for the width, length, and the amount of payload that it's going to carry? Which one are you going to do? Maybe we should just stop building ships until flat earthers work out a method of doing calculations without gravity. How about that?
Well, I think calculations are kryptonite where flat earthers are involved. Yeah. But if we look back at things, bridges back in antiquity, before we had this level of understanding of physics, most of them were so over-engineered. That's why they've lasted these thousands of years, because, you know, they just, oh, I'm sorry for these hiccups. They would just build a bridge with, you know, 4 or 5 times the material that was necessary.
Yeah, exactly.
I still don't see any flat earthers who are willing to take the challenge.
Yeah. No, well, they probably won't anyway. So there you go. All right. Okay, what was the other thing I had to discuss with this? So, okay, yeah. All right. So one of the things that's prominent on. Oh, actually, I had this particular one was quite great. I'm going to write something on my board and then I'll turn it on so that you can see it. So that Everybody loves this board. Okay, so here we go.
Yes, like I wrote you via email, it wouldn't be a Professor Phil presentation without the whiteboard.
Here we go. Just you can carry on your conversation. It'll just take me a minute to do this, okay? And I'll just writing some stuff down here.
Yeah, people in the chat are talking about pushytrons. I don't know if you've heard about pushytrons yet.
Pushytrons. Oh, that's Stingray's thing, isn't it?
Yes, it's taken the world by storm.
It was trying to Stingray acting like a flat earther.
Yes, he was a better flat earther than any flat earther.
It's amazing it hasn't stuck with him though. If they're not using his argument, I heard.
I guess they were on to him. Robert Kozlow wants to know what your PhD is in.
I'd rather not answer that, please. Okay.
No worries.
Yeah. But you rest assured it's in science. Plus, what have we got? Energy. All right. Okay, so I'll just turn the board on, and then we'll have a look at that. So I'll just put the camera up. Not sure if you can. Is the board visible? Okay. So can you see my board?
Yes, sir.
Okay. All right. That's good. So what have we got here? This is something that they've been laughing at on Nathan Oakley's show and Quantum Eraser's show. So I think most people would have seen this probably in primary school, I would guess. These two equations. Plants, this is called respiration. It happens both to plants and animals. But there's a lag, by the way, between what I say and the board because it's using a piece of software to run my iPhone through here, and there's a bit of lag because of the Wi-Fi. So this respiration. So plants are going to consume carbon dioxide and water. So six moles, the ratio of 6 moles of carbon dioxide to 6 moles of water and energy, which they get from the sun, photosynthesis, and produce 6 moles of oxygen and of course the glucose, the sugar. So effectively, how they make the wood. So the plants will use carbon dioxide, they'll use water, they'll get energy from the sun, there'll be some nutrients in that, and then the effect of that, all of that will be to produce oxygen and the wood. Now, if you're an animal, well, you've got the the sustenance, your energy that you go, the food that you're going to consume. So here you have the glucose. You're going to breathe in oxygen. You breathe out carbon dioxide and water. You want to make, if you want to see if you get water, blow your breath against a piece of glass, and or even your hand, and you'll see that it'll get slightly wet. So you know that it's producing water, and of course energy. You can lift your arm up and down. Okay. So, what is so funny about this? Flat earthers, please explain why this is not a thing. That's what I'd like to know. This is another one of those things that this is the latest thing that's going on. Who did they? I don't know, some famous scientists that they decided to have a go at who mentioned this. It reminds me of one there that they're going around saying bouncy ball boom boom, some crazy things that they're saying like this on Nathan Oakley's show, where it's decided to have a go at Thunderfoot, because Thunderfoot's sort of given them an analogy of particles, of gas particles being like balls, bouncing against each other and moving around like this. And I'm thinking, what the hell is wrong with that analogy? That's what I'd like to know. So maybe flat earthers in the chat can explain what's wrong with that analogy.
That sounds like a perfectly reasonable analogy to me.
Sounds reasonable to me. And then also explain this. Why is this funny? Why doesn't this work? What's wrong with these two equations over here? Is anybody in the chat going to explain why this is the case? Or is this another thing we can just reduce our arguments and just get rid of this out of your lexicon?
I think most of the flat earthers have run away.
Oh, okay.
But there is a little bit of drama in the chat that I regrettably am going to need to address.
Yeah.
So, and I apologize for taking up your time doing this, but Jose Gonzalez, I've been on his show for probably 3 years as a normal contributor. He and I never had any sort of disagreement, never had a bad word between ourselves. Absolutely cordial, and we got along fine. Now, in recent months, noticed that he acted a little odd, going on some other people's shows and trolling in their chats and things like that. So this past Saturday, I had the debate with Stingray and Bob the Science Guy on my channel, and Jose saw that there was basically a little flaw in our security. We had the link out there where it shouldn't have been, and rather than just telling me, on Discord or whatever, hey, your link's out there, it shouldn't be, he used that to join the show several times and basically disrupt the show that we were having, when all three of us were regular contributors to his show and had been, loyal contributors to his show. And I saw that as a level of disrespect that I'm not willing to put up with. And so I've cut ties with him. And I have not said almost nothing about it. I just said, okay, he's not the dude that I thought he was. I thought we had a level of respect between us. We clearly don't. So I'm done with him. And a lot of his loyalists have taken that to decide to attack me, and that's in the chat. There seems to be the need for me to explain that, and I have, and I will not do it again.
Yeah. Okay. I'll be honest with you. I'd rather not get involved in the politics of all of that. But I mean, obviously, from your perspective, and you need to do what you need to do for within your own, for your character. It is you. But if you like, I'll try to stay away from taking sides on characters. Okay.
Oh yes, sir. No, I was in no way asking you to weigh in on it.
Okay.
That's
Are you addressing the chat? Yeah. Okay, that's fine.
Yeah, I'm addressing the chat, but because
Okay.
it keeps coming up. I guess maybe it sounds like he's over on his show right now attacking me, and
Okay.
I preferred to just just walk away. We don't need to say anything to each other. That happened. If he wants to apologize, he clearly does. He clearly doesn't. So I don't have anything more to say about it.
Yeah.
And I don't need anybody to weigh in on one side or the other. So
fair enough.
I'm just saying it here is because it's a topic in the chat.
Because it's a topic, yeah. I get that. So one of the things that I'd like to just see if I can just reduce the amount of arguments as well again with this one, and that flat earthers again we'll take it back to the atmosphere, because apparently that's a contention for many things. In other words, if I say to them, I launch a rocket that contains a satellite. For instance, we did one in February 2017 that had 104 satellites on the one payload, which was a record. And so frequently, many satellites go up at once. And their argument is that, well, that can't happen because of the second law of thermodynamics. Okay. All right. So we'll say, well, what is this about the atmosphere? What's the issue with the atmosphere? They say you can't have an atmosphere next to a vacuum, and it's this word vacuum that I don't like. Okay. I don't like the use of that word vacuum because to the layperson, vacuum, they think about vacuum cleaners when they think about vacuum. They think about stuff that sucks things away. So let's just sort out some facts first. First of all, it's a fact that the atmosphere starts at 14.7 pounds per square inch, or 101.3 kilopascals, and gradually gets thinner and thinner. Thinner and thinner by meaning that there's less and less molecules of gas. Okay, so the pressure is less because there's less of it. The temperature is less because there are less things for the sun to heat up. Okay, there's less movement, there's less energy out there, and there's going to be less temperature. Okay, so in other words, the temperature is going to get less and less. So this carries on indefinitely. You start from 14.7 psi, and it goes less and less until there's practically none, and it just keeps going. There isn't a clear boundary where you say, all right, here we are, we've reached 100 kilometers or 60 miles, and all of a sudden it all stops. It just keeps going. It's just that the average amount of it where we can say, well, that we're affected by this is 60 miles or 100 kilometers. Say, right, okay, let's call that the atmosphere. It doesn't mean that there's a boundary at 100 kilometers where you've got gas and then no gas. That just never happens. So why is this question? Why do I continuously get this question? People like SE Montreal who comes on and says, how can you have gas next to a vacuum? Well, I'm saying, where does that happen? Who is arguing that there is gas next to a vacuum? Who is arguing that?
Nope, no one.
Okay? Take a 4B2 and hit them on the head with it, because they are telling you nonsense. If that's what they're telling you. So there's no such thing. So can you please stop saying that, and please stop asking that silly question? Okay? The question is silly if you're saying explain to me how we get gas next to a vacuum, because that's not what we're saying happens. So let's get back to the satellites then. All right. So it doesn't stop. Even where the satellites are, there are still gas particles. There are still things they're particles that will interfere with the motion of the satellite. The satellite will still degrade its orbit. So how far, if you've got this dome, then is the stone? How far is it away? Let's see. Geostationary satellite, 36,000 kilometers. Is it further than 36,000 kilometers? When the satellite orbits the Earth, it goes right around the Earth. Let's say the Earth was flat at the top. Where are the pictures from the satellite that tell us what's underneath it? You see how the flat earthers have to deny reality in order to make to make this nonsense work for them. They just flat out deny it, as if the thousands of people who are doing this are not. Now, let's talk about the satellite. Once a launch company, like for instance ISRO or SpaceX, they don't make satellites. Well, I suppose SpaceX are different, but the satellites, most of the satellites that they put in orbit, I shouldn't say they don't make satellites, they do. And even us at ISRO, we get companies who make satellites for us. So the satellites are turned over to their owners. So most of the satellites that are launched belong to other people. They don't belong to SpaceX or belong to ISRO or any of the other agencies. Lots of people put satellites in space. People with private money, private companies put satellites in space. Then the launch company, once they've done their job, turn over the controls to the people who own these satellites. What do they tell them? They paid all this money. What do they tell the owners? Do they give them a pretend controller, do they? The photographs that come from those satellites, they just pretend. There's somebody else in the space agencies who does these very, very fast CGI for the people who own this satellite. Do you believe all that stuff that you say? The flat earthers in the chat, do you believe that? Seriously? You seriously think the people who own the satellites, who get their images down all the time, the people who put the satellite there are making CGIs so that you can get them, so that the owners can get them all the time? Seriously, you believe that?
And that's the ridiculousness of it all. When I was in the Navy and was using satellite phones in the middle of the ocean, they were telling me that it was coming from ground-based towers, and I'm hundreds of miles from shore. It just the mental contortions that they can do to keep their worldview is awesome.
Yeah. Oh, absolutely. Absolutely. I mean, so if a flat earther wanted to know something, I could tell you the last one that was that I worked on is Cartosat 3, which is a mapping. It's designed to map the Earth, in other words. So it's got the best camera ever put on a satellite. It can actually take a photograph of 250 by 250 millimeter. So that's its accuracy, which is the best. Nothing's even close to that in terms of accuracy. So this satellite's job is it's in sun synchronous orbit. So in other words, it stays with the sun. So you want it to. Obviously, you don't want to waste time at night because you can't take photographs at night. So it stays with the sun, follows it in a polar orbit. So it's going about 5 degrees off the poles, and staying with the sun. And because the Earth is moving underneath the satellite, so the satellite's moving and the Earth is moving, the satellite eventually gets the entire Earth in about 12 hours. So that's how long it takes to take a photograph of the entire Earth. So how is it that this satellite could actually work if the Earth isn't moving around, if isn't going around? That is part of the deal. The people who own the satellite get the images. How can you deny that that happens? How can who's doing this image for them if it's not coming from the satellite? What about the mapping? It's used to actually produce the maps. How does that happen? Who's doing this? The people are just magic map makers. They're just brilliant. How do they get it right, these CGI people? Do you people in the chat who are flatties actually believe this?
Yeah, the number of people who would have to be in on these conspiracies is it would have to be nearly all of us.
Yep. What about somewhere around the Earth? At least one rocket is sent up almost every week. So you're looking at hundreds of millions of dollars if you look at the rocket and the satellite and the payload as well. And I've heard this silly thing. Correct me if I'm wrong. That they think the rocket goes up, goes around, and then is dumped in the sea.
Yes.
They actually believe that. So
the
every
majority
week,
that I've heard.
Yeah, so every week, hundreds of millions of dollars of equipment is just dumped in the ocean. How special do these flat earthers think they are? That these agencies would waste hundreds of millions of dollars dumping. Sometimes these satellites take 10 years to put together. So much work has gone into it. They're just going to dump them in the ocean. And the people who put them there, what are they going to say to the owners? The people who spent 10 years putting a satellite together, what are you going to say to them? Oh, the flatties told us to put it in the ocean. Yeah. Is that it? Is that what you're going to tell them? Sorry. Why do they keep coming back for us to put more satellites up there? Why do they keep coming back for more? If the first time they did it, we dumped their satellite in the ocean to please some flatties, why do they keep coming back with more? They give us another one to do. Flat earthers in this chat, do you seriously believe this? Do you seriously believe that? Or can you please now reduce the argument by that? Forget about the vacuum. Forget about the satellites being fake.
Here's a question I have. So let's say you're going to launch a satellite on a Thursday and that gets scrubbed for whatever reason. How much rework is there in the calculations that you would have to do? Say it gets scrubbed on a Thursday, so you're going to launch it Friday. Just that 24-hour period, what has to be reworked?
The whole thing has to be reworked because you cannot make a mistake. You can't get this wrong for any reason at all. So nobody leaves anything to chance. Okay. Now, what was the other thing? So somebody in the chat said something like satelloons, which is a flat Earth terminology, right? So in other words, what they're saying is that satellites are put on balloons. Well, I'll tell you what Queen Daddy QE didn't tell you, all right? The flat earther who thinks that. They didn't tell you that the maximum height of a balloon is 122,000 feet. That is because by the time the balloon gets to 122,000 feet, the density of the stuff within the volume of that balloon is equal to the density on the outside of that balloon. So therefore, there is no way for that balloon to go any higher up. The reason that the balloon goes up in the first place is because gravity causes the more dense stuff to take the place of, to displace the less dense balloon, and then it reaches a point where it cannot do that anymore because they are equal. So therefore, the balloon can't go any higher. How many brain cells do you need to figure that out? Now, can you please stop using that word satelloon as if we would hang $100 million satellite off a balloon? How crazy do you think we are?
Also, how would a balloon stay stationary?
By that point? And by the way, this balloon's struggling to get up there at 122,000 feet. You're going to hang a 4,000 kilogram satellite off it, are you? A 4-ton satellite's going to hang off a balloon that's struggling to get to 122,000 feet. Seriously, do you believe that? Sorry if I sound passionate, but God, it drives me wild when I hear some of this.
Yeah, that's why you're here. That's why we wanted you on.
Okay.
Let's look in the chat and see what we got. See if anybody's got anything. It's funny, I advertised this and they all ran away.
Oh, no doubt they'll pinch some sound bites and have a go at it on Nathan's show and, you know, say, oh, Professor Phil said this or that or whatever, you know. QE will call me a numpty, no doubt about it, for some reason or other. But, I mean, that's seriously, you know. What else did we have to cover? Oh, the sun. The sun is a big one. Shall we talk about the sun?
Absolutely.
Okay, so the sun. So the flat earthers talk about the sun being some sort of local, small thing. All right, so flat earthers. We've got rid of balloons, satelloons, we've got rid of, there's a whole bunch of things. Well, we'll summarize at the end of all the things that we no longer going to talk about in flat earth, okay? Because you know how silly they are. Let's get on to this one, the sun. Well, first of all, the sun produces about 3.8 by 10 to the 26 watts of energy per second. All right, per second. That is a lot of energy produced by the sun per second. And the earth gets about 4.3 by 10 to the 20 of that watts per second, okay, of that energy. That's a huge amount of energy that comes from the sun. Now, the first thing that you should know about why it can't be a small sun is because it can't produce that energy if it was small. It needs to be a big sun in order to produce, to make big energy. How's that? Is that sort of simple enough for you? It can't, a small ball out there, I don't know how big you think it is, doesn't have the capacity to produce 4.3 by 10 to the 20 watts of energy. The 4.3 by 10 to the 20 watts of energy is a fact. It's measurable. So let's look at the next part. The next reason why you want to throw out this small sun business. This small sun that you say produces photons from the entire magnetic spectrum, electromagnetic spectrum, all the way from gamma rays, less from gamma rays, but still got gamma rays, all the way to radio. It produces the entire spectrum. Can you please explain to me what process such a small thing could have that would produce this range of photons with the energy of 4.3 by 10 to the 20 watts per second? Now, one of the reasons that we don't get fried here by gamma rays and in fact X-rays and that, because these things do come from Earth, but they are attenuated by Earth's magnetic field. So, can you explain to us how this Earth magnetic field manages to do that for a small sun that's going around, that's traversing around this flat Earth model of yours, which we have already told you to put to bed in the beginning, remember? It's a load of nonsense, but let's just go with it. Now we've got this small sun that's going around. We don't actually know even what powers this thing to go around, but let's assume that you've got some magic going. How does Earth's magnetic field stop that small thing that's producing the entire magnetic spectrum, including gamma rays and X-rays? How does it stop that from hurting us? How is it that is even life on Earth, if that were the case? And what process could that thing possibly be doing with the size that it is that would produce those rays to match 4.3 by 10 to the 20 watts? Now, drop that small sun nonsense, because you can see from this very small description that I've given you that it's rubbish. It's nonsense. Lose it. Let's reduce the argument. Let's not include small sun in the argument, because that's just pure nonsense, as I have adequately pointed out to you.
Dr. Bell, we got a couple good questions. From Rodent of Anger wants to know, and I wanted to know this as well. Can you repeat the name of the satellite you were talking about so we can look it up?
Cartosat 3.
Maybe, Bull, can you type that in the YouTube chat? The name of that?
Okay. All right. I'll do that. Obviously, it's the third one.
The other question.
Late November. Yep.
The other question is from Clive Wells. Wants you to speak on the technical and financial scientific obstacles of Elon Musk's proposal to put 1 million people on Mars by 2050. He's incredulous, and he wants you to weigh in on that.
Well, I have to side with Clive. I think that's just politics. I don't think that's the amount of effort that would take, and the amount of energy that would take, the amount of expense that would take. Elon Musk is a rich man. He's not that rich.
Right.
Can you imagine the infrastructure that would have to be built there in the first place? Can you imagine who's going to take that infrastructure there? Just to take equipment 600 kilometers away is $36,000 per kilogram. Now, imagine building a shelter for 1 million people on Mars. It costs $36,000 a kilogram. You just imagine what it costs for each person up there. You'd be lucky if you could get away with $1 billion.
So it's self-promotion.
It's just promotion.
Yeah.
Yeah.
You can't be mad at him for that, you know.
No, not at all.
Yeah.
You know, just have the intellect to realize that it is promotion.
Right. He's done a lot for space travel, as far as I'm concerned.
Totally has. No doubt, and I wouldn't take a second of him. You know, the cars, the all of those things. Fantastic work, fantastic stuff, right? But you know, I mean, you know, you can throw a bit of poetic license in it as well, and that happens.
Yeah.
Yep.
Yeah, where I'm at here in Hawaii, I'm in on the Big Island, and right down the street is a Tesla showroom. They let you go and sit in the cars and look at them. He makes some pretty nice cars.
Okay, so somebody's explaining to me. I wrote that in. I see that. So Tusk says the sun is an electromagnetic, held in place by the polar opposites of the Earth. Okay.
What?
I think he's obviously having he must be joking. Yeah. Its
Probably.
glow is caused by the friction of rubbing on the interior of the dome. Oh, he's joking. Yes, of course. Yeah. Okay. All right, Mr. Tusk. That is very funny. Yes. Okay. Oh, okay. All right. Phew. He had me worried for a minute. Okay. Okay. All right. Okay. Look, so Flatties, can you please lose that small sun nonsense? Okay. All right. Because obviously that doesn't work. So remove that out of the model. All right. The other thing then following that is the moon. All right. So I've heard, correct me if I'm wrong, some flat earthers say the moon produces its own light. Is that true?
Yes, cold light.
Cold light. What's cold light?
It's nonsensical. A light by its very nature is electromagnetic energy.
I'm sorry, I don't know what do they say cold light is?
Well, it's to me it's nonsensical because light by its very nature is electromagnetic energy, which is energy.
Yeah.
You can't. What in the world is cold energy? That's just a non-starter. So I don't know.
Well, cold is just the absence of heat. Okay, there isn't actually a substance called cold, or a negative energy called cold. Cold is just Cold is just no heat. That's all. So you're saying that the light is no heat. Is that what they're saying?
That's what they're saying, but it doesn't make sense because light is energy, and energy is not. You would have to have the absence of energy, so you can't have energy and the absence of energy simultaneously.
Yes, the whole sentence that says that cold, the whole thing, that phrase is just nonsense. It's
broken.
It's broken. It's right. It's broken. All right. Now the other thing about it is that I was just thinking about is that the moon has its own light. Apart from the fact that you can see craters on it, if you just have a mediocre telescope, you can see the craters. Apart from that, who turns the lights off and on during the month?
Right.
And why do they turn? Why are they systematic about turning it a quarter of it on and then a half of it on and then a 3/4 of it on and then they turn the whole lot on? Why don't they just turn the whole bloody lot on all the time?
They're pranksters.
Flat earthers, do you seriously believe it? Or are we just going to remove this one as well from your lexicon of arguments? Why don't we just forget about that one? Because you and I both know it's nonsense, right? So let's not argue about the moon. We know that's not in the equation. But you do have to explain it, though. You're not getting away from it. We're not just going to forget that the moon exists. You need to come up with a better explanation, and not including that the moon has its own light, because you know that is pure nonsense. Okay. All right. So what else is there? Is there any other questions in from there? Oh, electron rockets. Okay.
Yeah, I'm not sure if you want to speak on that.
No, I don't know much about it. What else is there?
I had a personal question I was going to ask you.
Sure.
Well, not a personal question, but what's your thoughts on the Copenhagen interpretation? Or do you even have a?
No, I haven't even given that any thought. Even given that. So what do you think? Tell me.
Personally, I think it's probably the best that we have right now. So the many worlds theory.
Look,
it's probably not correct, but I think it's the closest thing that we have.
Look, I don't know. I mean, I like to follow what evidence there is for particle physics, and there's so much that we don't really understand about it. So I don't know. I haven't got a heap of time, to delve into all of this sort of stuff. So I'd like to. Maybe when I retire, I'll probably do some stuff on it. But quantum physics is a huge field, and you've just got to decide, where you want to be on it. I'm sort of more.
Right.
I do a lot of work with light and electrons and stuff like that. So, but electrons are actually quite large when you think about it. In terms of when we're talking about quantum mechanics, so electrons are on a large scale. We can actually apply Newton's laws of motion and momentum to electrons. That's how big they are.
I'd never considered that.
Yeah.
My bachelor's degree is in electrical engineering, and we were always fascinated by how small electrons were. But I guess you're right, on the quantum scale, they're pretty large.
Yeah, they are. I mean, they're large enough for us to identify them in terms of size, so and mass. And then, of course, there's the complexity of electrons having charge. 1.6 by 10 to the minus 19 coulombs. What's the electron mass? So I think it's about 9.1 by 10 to the minus 31 kilograms.
31, yeah.
Yeah, minus 31, and I think the proton is minus 27. So again, so protons, electrons, and so my field of expertise is in that sort of size, of particle physics. So I'll probably give myself away if I go any further into that. But yeah, that's my area of expertise in that sort of area. Quantum physics gets much smaller than that, and so where you're talking about massless stuff like photons, I know a reasonable amount about it, and I teach it. So momentum, classic momentum is mv, and yet and when we're talking about photons and the like, we're talking about energy being momentum over speed of light. At that stage there, we don't even include mass, because there's no mass to include anyway. And then, but when you're talking about electrons, large things like electrons and protons, classical physics works fine.
yeah, I'm much more comfortable in classical physics than anything quantum. But I think it was Richard Feynman who said, if you think you understand quantum physics, then you don't understand quantum physics.
Yeah. Oh, look, probably one of I've got a couple of heroes in physics and chemistry, and that's like Niels Bohr. And he's, he's sort of not that long ago, really, just, friend of Einstein, really. So, and then, of course, Planck, right? So,
And Max Planck.
Max Planck,
Max Planck.
yeah. So another one of my heroes. And then, and of course, my hero of all time was Newton himself. So, so it's really, though, I think those four people, brilliant work: Einstein, Planck, Bohr, Niels Bohr, and Newton. Yeah. So
And Einstein was a lot incredulous about the whole quantum thing. When he said God doesn't play dice and things like that, and
yeah,
spooky action at a distance.
yeah. Sometimes people will sometimes people say something and then it's taken out of context. I heard something that I found disgusting on Nathan Oakley's show, and he was putting down Tony Purcell, Dr. Purcell. He was putting him down because he said that he was a mathematician and that got into geophysics. And there's a lot of honesty and depth in that, in saying that, in telling people that, look, I'm a mathematician and I've gone into physics, and therefore, I'm limited into geophysics. So I'm limited by what I know about geophysics, and so don't ask me things about, maybe quantum mechanics, because it's not in my area of expertise. But that's the thing. It's you say, oh, he's got a PhD or whatever. That doesn't mean that they know everything. It doesn't mean that they can possibly have time to even know everything. I'm an educator, so I have a reason to try and to have a broad knowledge about things in physics and chemistry. That's because I'm an educator. People are expecting me to be able to impart some of this knowledge. But when when it's your job to just simply work in the field, you've got enough to know. You've got enough to do, working on the stuff that you have to in that particular field, without, saying, oh, I think I'll just go and read a book on quantum mechanics just for the hell of it.
Right. Well, we all bring various things to the table. I mean, I spent 22 years in the United States Navy, but I'm probably not the best guy to talk to about cruisers and destroyers, because I never served on a cruiser destroyer. I could talk to you in generalities about it, but that wasn't my area of expertise. So we all bring various things to the table, no matter our expertise.
Yeah, exactly. So I'm sure, for instance, one of the things I've been working on for about 10 years now is privately, it's my own thing, and that is I've been trying to work out how I can. I'm almost there, and working out how I can get a substance that will remove the alcohol, or change the nature of the alcohol that's in your blood, so that if you're drunk, like you've had too much, and we want to turn you from having a blood alcohol reading of X to no blood alcohol reading. Is there something that you could take, that you could consume, that could do that? And so that's one of the things that I've been working on, and nearly there. But I need more information. I need more about the medical side of it. See, I can do the chemistry. I can make the chemistry work. I can make the physics work about how to do that. But now I've got to approach this, because a human being is going to drink this. How's it going to affect their biology? I don't know enough about biology or cell biology for me to be able to predict exactly what that's going to do. I can just tell you from the chemistry point of view what it's going to do. I can definitely make that the alcohol disappear. But in doing that, am I going to create acidosis? In what way is the result of that going to affect someone's liver? You know, there's a whole bunch of questions I can't answer because I don't know enough about the biology.
Yeah, I'd heard rumors back during the Cold War about that the Russians were experimenting with something like that so that they could, you know, basically sit down and get drunk with somebody, but basically the interrogator wouldn't be drunk even though he was drinking, and so he could get information out of his interlocutor.
Yeah. Well, I'm not sure. I would hesitate on that. The reason is because the work that I've done on it, I've done some quite serious work, and people have offered me a lot of money to buy into it, and I've knocked it back. You know, millions of dollars. I've knocked it back because of the biology, because I don't know enough about it. And but what I did find was time is a factor. Okay, so because time is a factor, I needed at least in let's say, for instance, 9 liters of blood, needed at least 20 minutes for the process to happen properly. So I don't think you could be sort of drinking and no, I don't think that would happen. I doubt it. That's inconceivable from the process that I know. So I'm not someone who doesn't know about what happens. Like I said, I've spent 10 years on this, right? So I do know how it works, and I can't see that happening. That you could simultaneously it's not that. It's about 20 minutes to half an hour for 9 or 10 liters of blood.
Right. Yeah, there was so many rumors going around back then about, you know, various things that the Russians and the Americans had.
Yeah. So that's exactly. Yeah. Some good questions in there. Oh, Clive says that he's heard of this. It's called detoxahol. Okay, well there you go, Clive. It's people are actually working on it, and you're listening to one right now. So the other thing I did spend some time on, and then I gave it away, was looking at making a fiber. So a polymer. So you know how in hospitals they have sheets, and then they've got to take them. They take them to laundries and all of that. And there's a whole bunch of chemicals involved in that. So that's an environmental issue that we have to be concerned about with all of this, laundry that's happening with in hospitals. So I thought, well, is it possible for us to make a synthetic polymer? Maybe something that's even biodegradable, that we can use as a sheet in a hospital instead of a cotton sheet. Okay? And so that was one thing that my problem was that I couldn't get the polymer, I couldn't get that to sit to the sheet to fold like a just like a cotton sheet. It didn't have the same foldability, so it didn't sort of fall over you. You know what I mean? Fall over the bed like cotton does. It sort of went like a tent over it. So that was, these little problems like that. People working in science all the time to improve little things like that. And so many little inventions that are made that you don't hear them in the news. They just get done, and nobody, and quite often, and this has happened to me before, quite often you don't hear about this stuff because they end up being secrets, commercial secrets. So you never hear about what was the process by which this was invented or that was invented. You'll never know. Just like you'll never know what the ingredients to Coca-Cola is, for instance.
Right.
Okay?
We got a question here from, I'm going to butcher this name, Bjorn Eric Moen. It makes sense that Earth is round because it has a center point, which was pulled particles because of gravity. Why is the moon round? There is no gravity there. That's not a true statement.
No, it's not.
The moon does have gravity.
Oh,
Yeah, the moon has gravity.
Yes, not only has the moon got gravity, but we can actually calculate what the moon is. And so it turns out that the moon's gravity is about 1/6 of the gravity on Earth. So it definitely has gravity. The people who did end up on the moon, if they jumped up, they would fall down. They wouldn't just keep going. So if there was no gravity, they would just keep going. They probably wouldn't make it to the moon, and there wouldn't be a moon anyway. So there's a whole bunch of series of things would happen if there was no gravity on the moon. The whole notion of that there'd be no gravity doesn't make any sense. It's an object. It has mass. It's occupying some space in space-time, so it can't not have gravity.
Yeah, anything with mass has gravity.
Which is the other thing flat earthers say about gas. Are they seriously saying that gas doesn't have mass? I think I've heard that before.
I have heard that, and it doesn't make any sense. Even things as small, like what we were talking about earlier, electrons have mass, and therefore there's going to be a gravitational force on them. Well,
I mean, let's say you don't like the word gravity. Okay, let's say you just don't like the word gravity. It's to them it's like a swear word. Okay, call it whatever you like. You call it dropity if you want to, or whatever you like. Call it whatever you like. But the effect's still going to be the same. If it's got mass, it's going to fall. So I don't actually understand where the argument is that say, well, it can't be because gravity is not a thing. Gravity's not been proved, or some nonsense statement like that. So what? If you thought that, that's wrong. But if you did think that, so what? Does that mean the thing's not going to fall just because you say gravity doesn't exist? And what about this relative density nonsense? Where in the density equation is a vector? Which part of the density equation is a vector? Is a vector quantity? And please explain to me how you get a vector quantity from two scalars.
You don't.
Well, why is it you have people like that who seemingly, call themselves intelligent, will say something as outrageous as density has a direction, and therefore it will go down?
Well, if it was density the way they say it, then most things would go up.
You'd think it would head towards the area with less. I mean, they believe in they adopt the second law of thermodynamics to suit their means, and so you'd think that based on that alone,
right,
that would happen.
And then the ones that claim that it's some sort of electromagnetism. Well, water is diamagnetic, so water would float in their model.
Yeah, I got a chat from Tommy. I just want to, if you don't mind, I'll answer him, and that's from Rodent of Anger. Says that your polymer sheet is just like the movie The Man in the White Suit. Wow, and he said it's a great movie. I have to watch that because that might give me some insight into might get back to the polymer, to the sheet polymer. People told me that if I actually did that, I would make a fortune from it. But there you go.
Well, when you do, don't forget us small people.
Yeah, no, I agree. So the trouble is just like removing the alcohol, the detoxahol, as Clive put it, and that, life gets in the way, and then you just you'd love to spend so much time, but then you've got to make a living, you've got to pay the bills. So, and that's unfortunately they get in the way of doing science. Yeah.
So
Yeah.
it looks like we're not going to get any flat earthers.
No, I don't.
Is there anybody in the chat who has something to contribute that may want to link?
Oh, somebody said, "Oh, Clive's going on. Clive's gone nuts with his atmosphere." Yeah. So what is hard about understanding that in atmosphere? What's hard about understanding that if gravity affects everything, then even the gases that have mass are going to be held to the against the Earth? Why is that hard to understand? I mean, if you don't believe that gravity is has any kind of force, but you know that there's something that makes things fall. You know that things do fall if they have mass. Why can't you believe that the gases do that? What is hard about that? And understanding it, hang on a second, something? If there wasn't this, water wouldn't be the liquid that it is. It would be a gas. Why is that hard to understand? I mean, I agree that I'm not upset about people who don't know science. I mean, it's a discipline, and then you've got to learn a lot, and there's a lot of underpinning stuff to learn, but there's just things that are just common sense like that. I don't think you have to study science to figure that out.
No, it's just generally being aware of things. I think even the moon has an atmosphere. As rarefied as it is, there is some sort of atmosphere around the moon.
Yeah. So who is it Isla Moon?
Yeah, Ilya Moon. Her
Ilya
show
Moon.
is going to start in about an hour. Sit down with Debunkers, and she's got the link out there. Team Skeptic will be on her show.
Oh, so is Ilya Moon a debunker or flat Earth?
Yeah, she's on the right side of the team.
Oh, okay. Just the sensible side. Let's put it that way.
Yes, sir. She's one of us.
Oh, okay. All right. Fair enough. Yeah. Good on you, Ilya. Okay, that's good. All right. Yeah. I'm not actually pleased to see flat earthers who genuinely believe that the Earth is flat. I think I heard somebody say this. I think it was AB Science who said that there's victims, or was it? No, might have been Conspiracy Cats. I think he said it, that there's victims and there's grifters, and I think that's how it's turned out to be.
Yeah, that's pretty much my assessment of it too.
Yeah.
Bob the Science Guy says that there's flat Earth true believers, and there's the people who sell them T-shirts.
Yeah, exactly. So I think that's right, and so that lot up there that hang around together with the QE, they're definitely in the grifter range. Well, not all of them are on it, but I think that there's victims there. I think Arwen would be.
Arwen's a victim. Yeah,
he's definitely a victim. But I think grifters.
Yeah, you've got Quantum Eraser is a grifter, and
Oakley definitely.
Oakley, and then some of them are harder to tell. D Marble, I don't know. D Marble seems like he may be just dumb enough to actually believe it.
Yeah. Look, but Oakley said something interesting the other day, and he said that he doesn't make a lot of money from being a flat earther. He reckons he would be better off being on the other side of the fence, financially, and therefore we should believe him that that he's genuine. because otherwise he would be on the other side of the fence, you know. And I'm thinking that is almost an admission of the culpability.
Right.
That alone.
Yeah,
You know,
or
the
he
idea that you
could,
would contemplate that it's possible to be on the other side of the fence.
or he could just do like the rest of us and get a job.
Yeah, that's right. It's been a lifetime of getting a job, but no.
Yeah, you know, contribute
yeah,
something to society.
Yeah. There is the other thing about it, though. You know, when with someone like Oakley, and he's found a niche, and there are people who want to believe this, and they want to support him. Well, there is also part of me that says, so what? Why is it my business? You know what I mean? They want to give him the money. What is it? You know, I don't know. But then I would equate that. I'd say, well, would I say that about smoking, you know, tobacco companies? You know, would I say the same thing about them? You know, they're selling a snake oil and dangerous snake oil. So,
Well,
you know,
the thing with Oakley is he seems to be the epicenter of flat Earth arguments. Like he won't come out from behind his mute button and debate anybody. But basically, almost invariably, if you're debating a flat earther, you're debating Nathan Oakley because the arguments are going to be from him.
Yeah. Well, I argue it actually comes a bit further up the line than that's from Quantum Eraser himself. I think I don't think Nate Oakley does any research of any kind, but Quantum Eraser does. He looks for the cherry picking moments that he can.
Oh yeah,
no doubt. This episode here will generate some cherry picking moments for him.
Yep. Well, he's welcome to it. You know, he called me out. He called me out months ago, and said he had a surprise for me, and that surprise failed to manifest. So.
Yeah. Exactly. Yeah. Okay. Well, I've got to get ready for a lecture, so I think we've been about 3 hours now. So is it? No, 2 hours. Is it? 2 hours.
2 hours. Yeah, it was a good time. Sit down with the bunkers is coming up soon.
Yeah.
So
okay.
So, anybody in the chat? Final thoughts, questions? Dave, do you have anything?
And I just realized the audience never heard any of my questions because I had the master muted on myself. But the person who was supposed to hear them was hearing them, and that was you, Professor. So thank you.
Thank you. No worries. I must say I'm disappointed that QE didn't turn up like he said he would. You know, I didn't want to be. I wasn't. This was never going to be about bashing, you know, a flat earther or trying to humiliate a flat earther. I just wanted to narrow down the things that we're arguing about because the field is it's too wide. The argument is too broad. Narrow the argument down and find out what are the fundamentals that you disagree with, and then we can work on them, on these things and see. And then if you think we're wrong, you can show us where we're wrong within the confines of this narrow article. But if you just broaden it out, then everybody's just talking at each other, past each other, and nothing will be gained from it. Admittedly, the ones who are making a living out of this want that to stay like that. They don't want this to narrow down to you know, a handful of arguments, because obviously it eventually will affect their income. They want it to stay out there. But the people who, if there are such a thing, who are genuinely sitting on the fence, who genuinely want to know, you know, let's narrow this down. Narrow it down to the point where there's just a handful of things, or 2 or 3 things that we can seriously argue about, and then you'll get people like me being serious about it. Okay, because this flat earth thing's going nowhere without academics. I can tell you that now. It's going nowhere without us. You need to convince me that the earth is flat. I'm sorry, I can't say that without laughing.
Neither can I. Last question, I guess, from the chat is John Rapp wants to know when your next video is coming.
Okay, yeah, no, I've been so busy. I've got, because you got to appreciate this. We've got we're locked down in Melbourne, and then I've got so much assessment to do, because as we approach the so right until now, there's the assessments up to June and July. It's still going on, and then with the new semester starting, now, I'll have a bit of time coming up, but yeah, so I will be doing some shortly. Yeah.
Okay, Dr. Bell, thanks for coming on, and you're welcome anytime.
No worries. It was totally my pleasure. Thank you. And thanks
sir.
to those people in the chat who stayed and listened to this. I hope that, a man like me, please come and have a chat with me. He's still in the chat, and let's have a talk. We'll just discuss the stuff and see if we can't narrow it down. So a man like me in the chat, let's get it down. Let's narrow it down to to a few things that we can discuss, and then that we can actually look at the science, and then you can make up your mind then. And if you can convince me, well, that'll be something else, but I'm open to it. Okay, so get in touch with Straddling this cat. Come on the show. Let's have a little chat, and I promise you, I'll always be respectful. Okay.
Sounds good, sir. And I guess we will be hearing from you soon, sir.
No worries. You will too. Okay.
All right. Goodbye, everybody.
Right. No worries. Thank you. Thanks, everybody. Okay. Cheers.